This video will cover problems 20 through 24 on our first practice test. For problem number 20, we have the equation of a circle given, and we're asked to find out what the simplified version of that circle is, and then the domain and the range. In order to get this to where we can get a circle equation, you need to gather all of the x terms together. So you'll see I did x squared minus 8x. The red I did later, so I just left a blank, closed it out, plus y squared plus 10y, leave a blank, close it out. Now, that 2 is not helpful, so I went ahead and moved it to the right-hand side, and it became a plus 2 over there. Now, since my equation of the circle is x minus h quantity squared plus y minus k squared is equal to r squared, I need to get those binomial factors in there. Okay, no problem. I need to create a perfect square trinomial. So the constant that I always need has to be half of the coefficient of x squared. So you'd say, well, negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. I need to put a plus 16 here. If I add 16 to the left, I add 16 to the right. Same thing here in my group for y. I can say, well, I know that the constant I need to add is half of 10, 5. 5 squared is 25. I put a plus 25 here on the left. I add 25 on the right. Now, on this left-hand side, the whole reason that we completed those squares was so that we could go in and create a perfect square trinomial and then write that as a binomial squared. X squared minus 8x plus 16 is equivalent to x minus 4 quantity squared. Please remember, it's always the square root of the first term. You keep this sign, and then it's half of that number. If you took x minus 4 times x minus 4, it gives you that back. The trinomial of y is equivalent to the binomial y plus 5 quantity squared. Again, if you squared that out, you get this back. Now for my equation of the circle, I have the x minus 4 squared plus y minus 5 squared. On the right-hand side, we just get 18 plus 25 is 43. This tells me that the center of my circle, remember, it's always the opposite of these numbers in here. The center is at positive 4, negative 5, and it has a radius of the square root of this number, square root of 43. Now, for the domain, that's just what possible x values can be inside this circle. Well, you know that the center x value is 4. That x value could have the root of 43 less or the root of 43 more. That's where this domain is coming from. You'd say x starts at bracket, since it is a point on the circle, the lowest value would be 4 minus the radial length of 43, the square root of 43, and the high value would be 4 plus the root of 43. Similarly, for our range, you'd say, well, the possible y value is the lowest y value, and it's in there. You'd say bracket negative 5 minus the root of 43 up to negative 5 plus the root of 43 for the high value. Now, all of that has to be in our answer. For 21, we're doing a word problem similar to our last section. In this one, I just give a simple mixture problem. It asks how much of a 50% vinegar solution should be added to 20 liters of a cleaning solution that's already 30% vinegar to increase the concentration to a 38% vinegar. So this might be a scenario in which you need a certain percentage of vinegar to have a cleaning effectiveness. So we'd say, well, all right, we need a 38% solution. We're going to let X equal the number of liters of the 50% solution that's needed. So now I know that for every liter of that 50% I'm adding, it's going to contain 50% of the vinegar. So I'm saying the strength of the solution times the amount of this solution. So X liters times 50%. Plus, I already had 20 liters at 30%. I'm trying to keep the same order. Strength times the amount of solution. Strength times the amount of solution equals, well, the strength of the solution I want is 38%. The amount I know is going to be how much I already had plus the amount I'm adding, so X plus 20. Now, This should give me a nice, easy linear equation to simplify out. And I can do that. I just multiply the 0.3 times 20 on the left to get 6. On the right, I get 0.38 plus 7.6 when I distribute the 0.38. Now I can gather the x on the same side. 0.5 minus 0.38 is going to give me 0.12x. 7.6 minus 6 gives me 1.6 on the right. So now, in order to solve for x, I just divide by 0.12 on both sides. When I did that, I saw that 1.6 divided by 0.12 gave me 13.3 repeating liters. You could also say 13 1/3 if you prefer. But this is the number of liters of the 50% solution that you'd need to add to the existing 20 liters of 30% strength in order to get a total amount that's 38% strength. So 13.3 liters need to be added. 22 is an annoyingly easy problem. You've done linear equations since Algebra 1. It's just asking you to graph the equation in slope-intercept form, y equals negative 3x plus 5. So what you're supposed to know is that the constant gives the y-intercept. So we have the ordered pair 0, 5 is 1 point. And then that slope of negative 3. Well, it's the change in y over the change in x. The change in x is an understood 1. So you'd say, well, that means I go down 3, right 1 to get to my next point. That's precisely what I did. Down 3, right 1. So my x value increases 1 as my y value goes down 3. Another point on this line is the ordered pair 1, 2. Connect those 2 points, you have your line. That's all I need to see for the graph of your slope-intercept equation. 23 and 24 are more interesting problems. In 23, well, in both of these, we're finding the inverse and then proving that our answer is an inverse using a composition. Let me make sure this is not blurry here. I'll do that. There we go, that clears it up. Now, let me also clear up your understanding of this problem. For this first one, it gives you f of x is equal to 3x minus 8. All right, so if I know f of x is 3x minus 8, that's the same thing as y equals 3x minus 8. That's the original equation. Its inverse is going to undo whatever the original equation is, so it literally flips the x and the y values. That's what I have to do. Y becomes x, x becomes y. Now, the inverse will be when we can solve for the new y value. So I add 8 to both sides, and then 3y equals x plus 8, so y is going to equal x plus 8 divided by 3. That solution for y can better be called the inverse function. So I'm confident that the inverse of f of x is equal to x plus 8 over 3. But now I need to show that by using a composition. So I need to show f composed with f inverse of x is equal to x. If I plug the inverse into the place of x in the original function, I'm left with 3 times the group, x plus 8 over 3 minus 8. This is supposed to equal x. Well, does it? Over here, the 3's would cancel. You would have x plus 8 minus 8. And at that point, you can see that you can eliminate those 8's, and you would just get x on the left-hand side. And as soon as you do that, you say, yeah, the composition did simplify down to x, thus this inverse was correct. Now for 24, it's just a more rigorous and fun problem of 23, where I'm giving you a rational function for your original. And you say, okay, so the original function is the same thing as y equals 2x plus 7 over x minus 4. Its inverse is going to flip those x and y values. So you're going to have x is equal to 2y plus 7 over y minus 4. Now you need to solve for the new y value. In order to do that, you need to get y out of the denominator. So I multiply by y minus 4 on both sides to begin with. And then I need to get out each individual term. I don't want any multiplication, so I distribute the x on the left. So now I can write individual terms of xy minus 4x is equal to 2y plus 7. That was a big step because now I can get every single term that has a y on the same side, every other term on the other. So you'll see I have xy minus 2y on the left, the 4x moved to the right and became positive 4x plus 7. Now that I have every y term on the left-hand side, I can factor the y out. So I can say if I factor the y out of that group, it's going to leave me with an x minus 2. That's still equal to 4x plus 7. So y times x minus 2 is equal to 4x plus 7. That means y is equal to 4x plus 7 divided by x minus 2. And instead of saying for y equals, as soon as you solve for y, you can call it the inverse function is equal to that. So I am confident f inverse of x is equal to 4x plus 7 over x minus 2. Now I need to show how confident I am by proving it. I do the inverse, I do the composition. F composed with f inverse of x better simplify to be x. So I'm plugging the answer I got for the inverse in for x in the original function. So that gives me 2 times the inverse plus 7 over the inverse of f minus 4. Now, this is a compound fraction, similar to an earlier problem we had in this assignment. In order to simplify it, you must multiply by any denominator on the fractions within that fraction. So you just say, well, that's just x minus 2. I multiply both my numerator and denominator by x minus 2. When I do that in the numerator, it's going to leave me 2 times the group 4x plus 7. Then I'll have plus 7 times x minus 2, all divided by 4x plus 7. But now don't forget that x minus 2 also multiplies that minus 4 in the denominator. From this step to the next, I just need to carry out the distributive property everywhere in the problem. The 2 distributes through this group and I get 8x plus 14. And then the 7 distributes through and I'll get plus 7x minus 14. In my denominator, 4x plus 7 was not multiplying anything. The minus 4 distributes through and I get minus 4x plus 8. Now, in this step, I know this is equal to x. And please notice, oh, it is. In your numerator, the 14s cancel and you have 8x plus 7x is 15x. In your denominator, the x terms cancel and you're left with 7 plus 8 is 15. 15x over 15 gives you x, which is excellent because that proves that your inverse is correct. All right, this concludes our video solutions to our practice test 1. Hopefully you think this is as fun as I do. Well, no one thinks it's as fun as I do, but hopefully you do find it fun. And please let me know if you have any questions. I look forward to seeing many of you there testing with me next Friday in Goins Auditorium. It's Goins 136.